Hi guys, and thank you so much for watching my channel, The Witty Turtle. In this class, we will understand how many kinds of queuing models the managers or the analyst use to make a proper queuing system, right? So, in this discussion, we are basically going to study four kinds of queuing model, and the purpose is to provide an exposure to a variety of models, right? To different kinds of models. Okay, so all these kinds of model, they assume a Poisson arrival rate. So what is the meaning of Poisson arrival rate? So you must have studied this Poisson method in statistics in your CMA foundation or in your BCom or BBA examinations. So Poisson arrival rate का मतलब होता है कि depending upon some historical data or depending upon some kind of data, you are determining a particular rate of happening of particular work, right? For example, on the basis of historical data, you can assume that yes, this particular region of India might face heavy rainfall 15 or 20 times in a year, right? So this is based upon Poisson arrival rate, and other than these results which are found through historical data, other than any such result, those are vague. So this is known as your Poisson arrival rate. If you want to know in detail, then you can search for any video on YouTube. Moreover, the models pertain to a system operating under steady state conditions. They assume the average arrival and service rates are stable. So what is happening here? So they are assuming that all these queuing models are operating under a steady condition, right? And also the average arrival and service rates, those are constant or those are stable, right? So what are the four models described here? The first one is single server exponential service time. So that means only one server is there and the service time can vary. That might vary. The second model is single server constant service time. So here what is happening? There is only one server and the service time of that server is constant, right? The third model is what? Multiple servers exponential service time. More than one servers are there and the service time is varying. And the fourth one is multiple priority service and exponential service time. That means multiple servers are there, but they are functioning on a priority basis. And again, varying service time are there, right? Server and channel, these are the same things. Okay. Now the important part comes in this chapter, that you have to memorize all these symbols. Okay, so what are the infinite source symbols? So through these symbols only we are formulating the formulas, and we can calculate the answers from those formulas. The first one is customer arrival rate, that is denoted by lambda, right? So what is the meaning of customer arrival rate? How many customers are coming to your queuing system, right? That is your customer arrival rate. The next is mu. What is that? Service rate per server. From one server, how many services are happening, right? And another thing is that like below the table, one note has been given that the arrival and service rates represented by lambda and mu must be of the same unit. If it is customers per hour, then both of these will be customers per hour, right? Both of these will be customers per hour. And if it is denoted in minutes, then both of these will be customers per minute, right? The next one is LQ. LQ is what? Length of the queue, right? L for length and Q for queue. So the average number of customers waiting for service, they are waiting in the queue. So it is very easy to memorize. It is LQ. The next is LS. S for system. So that is what? The average number of customers in the system who are either waiting or they have already been served, right? So the total number of customers basically. The next is R. This is the average number of customers being served. This is what? The average number of customers who have already been served. The next is rho. This is not P. Many people read this as P, but this is known as rho. R-H-O, rho. The system utilization. इसका क्या formula है? We will study that after completing these. Okay. The next is WQ. WQ क्या होता है? The average time customers are waiting in line. Like what is the average time for which the customers are waiting in the line? That is your WQ. Waiting and queue. Next is WS. Now just imagine this is the average time customers spend in the system. Right? In the system. That means the system includes both waiting in the line and the time taken for providing the service. Okay. The next is your service time. So service time क्या होता है? 1 by mu. Okay, 1 by mu. The next is P0. This is P. This is not rho. Okay, don't get confused. P0 क्या है? This is the probability of 0 units in the system. Like what is the probability that 0 people will be there in a queue? Next is Pn. So the probability of n units in the system. Obviously, if this is probability of 0 units, then n is the probability of n units. Like if you have to calculate the probability for 50 units in the system, then this will be P50. Understood? The next is M. M is the number of servers or the number of channels available in the queuing system. The next is L max. The maximum expected number waiting in the line. What is the maximum expected number who are waiting in the line? That is your L max, right? If you are unable to remember all these things, then you can simply write them in the copy and you can try to memorize them, okay? Now the next is the basic relationship that is valid for all infinite source models, right? So what is the basic relationship? The first one is system utilization. So what do you mean by system utilization? Obviously, it is the ratio between the demand to supply or the capacity as measured by the product of the number of servers, right? So basically इसको ऐसे याद रखो, system utilization is the ratio of demand and supply, okay, or the capacity utilization. So what is the formula for this? The formula is capacity utilization का symbol क्या था? That was rho. So rho equals to lambda, that is your customer arrival rate. Lambda divided by m into mu. Okay. So customer arrival rate divided by your number of servers into service rate per server. Obviously. So through this you can calculate your system utilization. Let's take an example. For example, your lambda is 10. Okay. Like 10 customers are coming in the queue and you have 2 servers and your service rate per server is 5. So what will happen? 10 by 2 into 5, that will be equal to 1. So this means the system is getting utilized 100%, right? System का full utilization हो रहा है. If this the value of rho is more than 1, that means what? अगर ये more than 1 हो रहा है, that means your numerator is more than your denominator. So numerator is more, that means more customers are coming in the queue and you are unable to satisfy their needs, right? You are unable to cater them. So if the value of rho is more than 1, that means more customers are coming and the capacity of your system is less, right? The next basic relationship is the average number of customers being served. The average number of customers being served. So what is the symbol for that? The symbol is R. So R equals to lambda by mu. Lambda by mu. Like how many customers are coming divided by per server, what is the service rate, right? Now here we can see another formula, that is your LS. LS क्या है? Average number of customers in the system, और we can say like total number of customers in the system जो लोग wait कर रहे हैं and जिनको हमने serve कर लिया है. So इसका formula will be LS equals to lambda into WS, right? And LQ का भी similar है. LQ equals to lambda into WQ. So here another table has been given, like customers or ये line service system. This is very easy. You can like understand it by yourself, right? Now the average number of customers. So this formula we have already studied. And the second is what? Waiting in the line. The average number of customers who are waiting in the system. So waiting in the system means who are waiting in the line plus those customers who have already been served. So what is the formula for that? LS equals to LQ plus R. LQ plus R, or LS equals to lambda into WS, right? अब आपको ये लग रहा होगा how to remember all these formulas. Simply take out a paper and write every formula there and stick it somewhere where you can read it multiple times a day, and that way you will be able to memorize everything. And along with that, when you start solving the questions, you will apply these formulas, and that way you will remember everything. Now the average time customers are waiting in line or queue. So average time वो लोग जो वेट कर रहे हैं वो एवरेज टाइम का सिंबल क्या है? WQ. So from this formula only you can derive this formula. You can lambda को आप नीचे ले आना, that will be your LQ by lambda equals to WQ, right? And similarly waiting in the system, those who are waiting in the system, इसका क्या फॉर्मूला हो जाएगा? एक तो हो जाएगा आपका WS equals to LS by lambda, ये एक फॉर्मूला हो जाएगा, and the second formula will be WS equals to WQ plus 1 by mu, right? 1 by mu. This is your second formula. If I'll start deriving all these formulas, then the classes will be very long and it will be difficult to complete your syllabus, right? So I'm not deriving everything. Simply you need to memorize these, and ये memorize हो जाएगा. इसमें मतलब this is not very difficult. All infinite source models require that system utilization be less than 1. The models apply only to underloaded systems. Obviously, as I have said earlier, that if the value of rho is more than 1, that means customer dissatisfaction. And so obviously आपको the value of system utilization should always be less than 1, right? And LQ will usually be one of the first values you will want to determine in problem solving. That means while solving a problem, which one is the first thing that you need to calculate? That is your LQ, right? Okay, coming to the first illustration of queuing model, that is your illustration number 7. Question says customers arrive at a bakery at an average rate of 16 per hour, right? 16 per hour on weekday mornings. So the arrival rate क्या हो जाएगा यहाँ पे? Arrival rate, that is your lambda, that will be your 16, right? And this is mentioned in which unit? Mentioned per hour. The arrival can be described by a Poisson distribution with a mean of 16. With a mean of 16. Each clerk can serve a customer in an average of 3 minutes. In an average of 3 minutes, right? So 3 minutes में the clerk is serving one customer, right? So it is taking 3 minutes, one customer. So in an hour, how many minutes are there? 60 minutes are there. So how much time it will, the clerk will serve how many customers? 20 customers, right? Understood this basic maths? Okay, this time can be described by an exponential distribution with a mean of 3 minutes. Okay, with a mean of 3 minutes, right? So the first question is, what are the arrival and service rates? So arrival rate kya hai? This is directly, that is your 16, right? So 16 customers per hour, that is your arrival rate or lambda. Now the second thing that has asked in the question is service rate. Okay, so what do you mean by service rate? Now here one thing that has been given to us is service time, right? Service time is what? So what is the symbol for service rate per server? That is your mu. So see, one clerk is serving one customer in 3 minutes. So how many customers the clerk will service in 60 minutes? 20 customers. So this is your mu. Mu is equals to 20 customers per hour, right? 20 customers per hour. If you imagine the situation and you start solving the question, then it becomes easier. Okay. Okay. The second question is compute the average number of customers being served at any time. Compute the average number of customers being served at any time. So average number of customers का क्या था symbol? The symbol was R. So R equals to lambda by mu. Simply put the value and get the answer. Lambda is your 16, mu is your 20. So your average customers being served at any time is 0.8 customer. Okay, this is the value. Now the third question is, suppose it has been determined that the average number of customers waiting in line is 3.2. That means your LQ is 3.2. Compute the average number of customers in the system. It is asking you to calculate LS. Okay, the average time customers wait in line, that is your WQ, and the average time in the system. Okay, so one value has been given to you. Here we understood what you have to calculate LQ first, because LQ मिल जाए तो आपको बाकी सारे values you will automatically get, right? So the value of LQ has been given here. Simply you need to calculate your LS, WQ and WS, right? So LS का क्या formula है? Your LS is LQ plus R. So what is the value of LQ? It is already given in the question, that is 3.2, and R का value हमने अभी निकाला है, that is 0.8. So obviously here your LS will be what? 3.2 plus 0.8, that will be 4 customers, right? 4 customers. Now average time customers wait in the line, that is your WQ, waiting time in the queue. What is the formula for that? LQ by lambda. The value of LQ is 3.2 and the value of lambda is 16. So it comes as 0.2 R. So इसको अगर हम minutes में convert करें, then it will come as 12 minutes, right? This is basic calculation only, right? So here I have a derivation of like ये कहाँ से आया, कैसे आया. So you can go through this, and अगर confusion हो रहा है, then do let me know in the comment section below. Now WS equals to your, now you have to calculate WS. So what is that? Average time customers are waiting in the system. So what is the formula for that? WQ plus 1 by mu, right? So the value of WQ is what? 0.2 hours plus mu ka value is 20. So 1 by 20. So this is coming as 0.25 hours, or that is equal to your 15 minutes. Understood? Okay. Let's see what is the next question. Determine the system utilization for M equals to 1, 2 and 3 servers. Okay. When you have 1 server, 2 server and 3 servers, then what will be the system utilization? Okay. So what is the formula for system utilization? Rho equals to lambda by M into mu, right? So M equals to 1, then you have rho. So rho का क्या हो जाएगा? Your the value of lambda is 16 and the value of mu is 20. So ये दोनों constant हैं, right? The only thing that is changing is the value of m. So ये क्या हो जाएगा? 16 divided by 1 into 20, that will be 0.8. Then you have when you have 2 channels or 2 servers, so in that case what is happening? 16 divided by 2 into 20, that will be 0.4. Then you have 3 servers, so rho equals to 16 by 3 into 20, that will be 0.27, right? So here you have to note that as system capacity is measured by m mu, when m mu increases, the system utilization for a given arrival rate is decreasing, right? So when the number of servers are increasing, that means your system utilization is decreasing. M increase हो रहा है, rho आपका decrease हो रहा है, right? So this class I am ending here only. If you find this video helpful, then please hit the like button, subscribe to my channel, The Witty Turtle, and also share this video with your CMA Inter friends. And you can follow me on Instagram. I'm posting some really good content over there. And in the next class, we will start this.